we talk about all this weather, I hope you haven't gotten your head stuck in the clouds, but even if you do, welcome back to Skybound on the Ground with Michael Lombard. We're on to part 3 of weather theory, and this is going to be a short and sweet lesson as we talk about air masses and fronts. I was just looking at this confusing sign, front and front. Well, I made that sign because we're actually talking about fronts, and there's really no back-to-front stuff about this. And so let's go ahead and talk about it. First of all, air masses. What is an air mass? When we talk about air masses, we're talking about big pictures. So we can look at maybe something like the continental United States here. And air masses are bodies, large bodies of air that take on the characteristics of the surface that is beneath them. So you might have an air mass that's up here, and because it's close to the pole, it takes on this polar characteristics. It's going to be cold, and if it's over the land, it'll be polar continental, and it'll just be this cold, dry air. If it's over like water over here, it'll be this cold maritime air, and it'll be moist and stuff. So you have these air masses, and air masses don't just stay still. They tend to move around a bit, and when they start moving in a certain direction, then you get what's called a front. And a front is simply the boundary between one air mass and another. So you get different types of fronts, and you've probably heard about fronts on the weather system, on the weather forecast, when they talk about various weather systems that are moving around, and they'll say we have a cold front moving through the area through the a couple days from now, and it's going to bring this type of weather. Well, how does it even look like? What is a cold front? What's a warm front? Well, let's take a look at how they depict it first of all in when they draw it on a chart. When you have a warm front, they are going to depict it with a red line if you have it in color, and it'll have these little half suns on there, and that's the direction in which the front is moving. And simply put, this is warm air that is displacing itself, that's moving itself into, or moving itself towards a direction where there's colder air. And so that is the direction in which it's advancing. If you have a cold front, this is cold air that is going in a particular direction, and they will have these little like little spikes, little like icicles on there. And it's blue because blue is a colder color. So that's how they depict cold fronts and warm fronts. You also have something called a stationary front, when you have a combination of the two, and then you will have them depicted like so. And so you will see a warm front pointing one way and a cold front pointing the other way. And this is just when you don't have either one moving either direction. They're just staying there. And so I can say it for quite a while. This is called a stationary front. There's one more case, and this is usually depicted in purple, but I don't have a purple marker, and that is called an occluded front. And this is when a when a cold front is overtaking a warm front. And so you get a mix-up going on, and this is called an occluded front. And you will see the icicles and little half-suns depicted there in the symbology. Okay, so let us talk about the general characteristics of fronts. These are just very generalized principles because there's no two storms that are exactly the same, and weather systems are always, there's always something different going on. But meteorologists have been able to come up with some generalized principles of what you can expect from cold fronts and warm fronts. Let's start off with a warm front. And these go over quite a few miles, and we're just going to use the example that the book gives us of, say, like 4 different cities that are each 200 miles apart. So you get out 400 miles, 600 miles, and we have a warm front that's going through. Now, warm front, you got warm air, and what tends to happen, warm air is rises and it goes higher. It'll actually extend up and over the cool air that it's trying to displace, and it'll go like that for quite a few hundred miles. And then finally at the very back here is the frontal boundary. So this is the warmer air, this is the cooler air over here, And what you end up getting is weather developing as a result of the difference between temperatures. Over here, you'll have these high clouds, like cirrus type clouds, and then as you get closer and closer to the front, you'll have different types of lowering clouds. You'll have the alto stratus type clouds, and then you'll have stratus you'll have these cirrostratus clouds, and then altostratus clouds, and then finally over here close to the front you'll have these nimbostratus clouds where you get the rain and the low ceilings and stuff. So warm fronts tend to be slow moving, and they give you a lot of advanced warning of when they're coming, because you have these clouds that extend for several hundred miles in front of the actual front itself, in front of the front. I should say ahead of the front. So here is where the front is, and if you look at it from the top, it would kind of look like this on the map. And so you tend to get, what you'll tend to get is poor visibility, rain, low ceilings, so just kind of mucky stuff. And that's with the warm fronts, and it can take several days for it to actually pass by and for the weather to improve. Now let's compare that and contrast that to a cold front. Cold fronts, whereas warm fronts are slow moving and they tend to be, they move from like 10 to 25 miles per hour. Cold fronts tend to be faster moving, and some of them can be very fast moving. So they'll either be 25 to 30 miles per hour, or some of them have been clocked at going up to even 60 miles per hour, and that's fast stuff. Cold fronts tend to have more of a steep frontal slope to them, and they act more like a snowplow. So if you look at it, this is what it'll look like. Here's the cold air that's shoving its way forward, and here's the warm air. And because of that, you won't get as much advanced weather in terms of stuff in advance. You will get some cumulus whatever clouds in front, but then most of the weather tends to be concentrated right on the frontal boundary, and you will get turbulent type clouds. This is where you get thunderstorms. Cold fronts tend to bring violent weather and turbulence and icing and stuff like that. Hail from the thunderstorms. And you can also have associated with cold fronts is something called squall line thunderstorms. These, although they sometimes tend to develop in front of fast-moving cold fronts, and let's just depict that down here again, they can also be up to 200 miles ahead. So they aren't always associated right in front of the cold front. So squall lines, those are narrow bands of very active thunderstorms, and we're going to talk a little bit more about that in just a few minutes. That's stuff you want to stay away from. So cold fronts, they're fast moving, they tend to bring more violent weather, turbulence, and they also clear up quicker as well. And so that is the difference between warm fronts and cold fronts. Let's take a look at an occluded front, and this is kind of a weird thing. And this is where you have a cold front that is overtaking a slower moving warm front, and what it'll look like is something kind of like this. So you have the warm air that's making its slow movement forward, and then you have this cold air in front and colder air in the back here. And so this is all moving this direction, and what you'll end up getting is warm front weather around here, and then it'll switch over to cold front type weather. So you get a mixture of both, a combination. And then of course with the stationary fronts, you get a mixture, and with the cold fronts you get a combination. With the occluded fronts you get a combination. I'm just getting my terms mixed up here. And thunderstorms, remember, we often get thunderstorms with cold fronts, and thunderstorms are those hazards that we definitely want to avoid. In order to have a thunderstorm, you have to have three primary ingredients. First of all, you have to have moist air. Then you have to have, that air needs to be unstable, and a way you can recognize unstable air is by its lapse rate, and that's the the rate at which the temperature cools as it gets higher. If it's got an unstable lapse rate, it's going to cool very quickly as you go higher in temperature. Cooler than it's going to have a higher than normal rate of cooling, if that makes sense. And so you have to have an unstable atmosphere, moisture, and then some sort of lifting action. During the summertime, you will often get these air mass thunderstorms that result from the lifting action of just air that's heating up by the surface because of the hot day, and then that will burn off by the end of the day, and then things quiet down again. But if you have frontal activity, that can produce lifting action because of this air that's getting pushed up by the front, and that will produce these steady state thunderstorms. And steady state thunderstorms that are associated with weather systems, they last longer and they are stronger. So live longer, live stronger. These type of thunderstorms, we really don't want them to live longer and stronger, but these are the ones that produce pretty violent weather and last for quite a long time. You can get these squall lines, which can oftentimes form ahead of a cold front that can be up to 200 miles in advance, though. And so these are narrow bands of active thunderstorms, and they can extend for hundreds of miles. So it's really pointless to try to penetrate through or try to go around, because they can just pop up like right in front of you, and they're just going to block the way, and they have violent weather in them, and they can last for hours. And so you just want to get on the ground and avoid these squall lines, period. Now, when you have a front that passes by, you're going to always have a change of wind direction. So you could have the wind blowing from, say, the southwest at say 25 knots. Each of the full barbs represents 10 knots. That half barb, each of these little feathers on this barb. Each of these feathers symbolize 10 knots, and then the half feather symbolizes 5 knots, and then the direction is where it's coming from. So that's a southwest direction. And then as soon as the cold front passes, then you have the wind suddenly shifts direction, and it's actually going to be maybe from the west, northwest at 20 knots. And so you're always going to have a shift in wind direction associated with the front, and you can actually tell when the front has passed based on that wind shift. And just always remember that fronts bring with them a change in weather. And so that is front stuff. And just a little bit more about the thunderstorms. Thunderstorms bring hazards with them: tornadoes, shear turbulence. Remember, you have updrafts and downdrafts that are going on inside the clouds. One moment you can get bounced up several thousand feet, and the next moment you could be going straight down several thousand feet. And you get super cool large droplets in there that turn to ice when they hit your airplane. Hail, especially beneath the anvil of the thunderstorm. So even if it's clear air, don't fly underneath that thing right there, because you can get pummeled by hail. And lightning and water ingestion, drowning your engine. So lots of stuff associated with thunderstorms. And if you have cold fronts moving through, remember, cold fronts are going to often bring violent weather, and warm fronts are just going to bring lousy weather. So as a VFR pilot, you got to pay attention to frontal locations if you're going to do a long flight. You want to see where those fronts are, where they're planning to be during your flight, because you may just have some weather on your hands, and you don't want to fly into the weather. You want to make sure you keep clear of that and are able to see things clearly while you're flying. So that wraps up our chapter on weather theory. We're going to start dealing with how we can get our weather forecasts and interpret them in the next lesson, when we move on to chapter 12, aviation weather systems or weather services, next time on Skybound on the Ground. See you then.